Hi, welcome back to the Mind Math by McGraw-Hill tutorial. My name is Mr. Galvez, and today we'll be looking at Chapter 12, Geometry, Lesson 5, Classifying Quadrilaterals. I find this lesson to be rather fun, mostly because I get to play again with the protractor to measure angles. I'll be working with a ruler. In this case, I'll be working with centimeters because I'll be working with the smaller size quadrilaterals. Now, to begin with, we'll remember that quadrilaterals are four-sided shapes that are in two dimensions. As you may remember, quad means four, and laterals means sides. So we're gonna have two-dimensional shapes that have four sides, four angles also. I'll be using words such as congruent sides. Basically, that means sides that are equal, sides that are the same. Parallel sides, these are opposite sides that will not meet, kind of like train tracks. At no point will they cross each other. And I will also be using the terms right angles. And these are angles that measure 90 degrees when you use a protractor. So when you look at a window or a door, the corners that you see on the windows and doors, they tend to be square. They tend to be 90-degree angles. The first quadrilateral I want to look at is a rectangle. The rectangle is a quadrilateral where you have two opposite sides that are the same length. In this case, I'm going to draw one side to be 6 centimeters. I will need some right angles. So here's a protractor. The right angle is going to be 90 degrees. 90 degrees here. 90 degrees over here. Now, if this measures 6 centimeters, for a rectangle, this side, I'm going to want it to not measure 6 centimeters. In this case, I'll make it go up 3 centimeters. This opposite side will go up 3 centimeters. Now, if this is 6 centimeters, this opposite side on the rectangle will be the same length. Okay. So these two sides are same length, and these two opposite sides are also same length. I'm going to have a rectangle. I will have 4 right angles. And finally, I do have parallel opposite sides here that are certain length, and parallel sides over here that are a different length. Okay, so that's a rectangle. A square is basically the same thing, except all sides will be the same length. Okay, so if one side measures from 0 to 3, all my sides will have to measure 3 centimeters. And if it's a square, all sides will have to be right angles at 90 degrees. I mean, use this protractor to make my 90 degrees. 3 centimeters there, 3 centimeters over here, 3 centimeters over here, and also 3 centimeters over here. Okay, so every length is equal. We do have 4 right angles, 4 angles that measure 90 degrees. And we also have opposite sides that are parallel and they happen to be parallel and the same length. Okay, so that's a unique feature about the square. We got we have two pairs of opposite parallel lines, just as a rectangle, except just that all the lengths are equal. Now, when we move down to the parallelogram, this is the way I think about the parallelogram is like a rectangle, but slanted, like someone sat on it. And so we don't have 90 degrees anymore. Parallelogram, we do want to have opposite sides that are parallel. Here I'm going to go from 1 to 4. Now, for the angles, here's 4 centimeters. I'm going to have the opposite side at the top also measure 4 centimeters. For the angles, I don't want 90 degrees. I can't have 90 degrees. So I'm going to have less than 90 degrees. I'll shoot for, let's go with 60. No, let's go with 50. 50 degrees and 50 degrees. Okay, I just ensure that these two lengths are the same. From here to here measures 3.5 centimeters. This was 4. This top line should measure 4. Okay, so in a parallelogram, I'm thinking of a rectangle, but that's slanted. These angles, these opposite angles are equal. These opposite angles over here are different, but they're equal to each other. These side lines are parallel to each other. These opposite, the top and the bottom lines are also parallel to each other, but they're not the same length as this side. Okay, and last but not least, this side is the same length as this opposite side, and this side down here is a different length from the top. So a lot going on over here in the parallelogram. But we will see that a parallelogram has the same attributes and qualities as a rectangle and a square. So a rectangle and a square can be thought of as parallelograms. Okay. Now for the rhombus, we have another parallelogram because we're going to have opposite sides that are parallel. Except for the rhombus, I think of it as, you can think of it as a square that has also been slanted. Okay. And so I'm going to need 4 lines for quadrilateral. I'll start here with 3.5 centimeters, 3.5 centimeters. Okay, so I'll draw that line. That'll be my baseline. I will need some angles that are not 90 degrees because the rhombus is, think of a square, but slanted or bent over. And so I don't want 90. I'll go with, let's go with 70. 70 over here. 70 on this side. Now, if I said this was 3.5, then this side also has to be 3.5. And this side will also measure 3.5. I think I didn't get this to be 3.5. No, I measured at 3. I wanted to go 3.5, 3.5. And that's going to ensure that this top line also measures 3. There it is, 3.5. Okay, so the rhombus will have all sides equal length. Okay, so these opposite sides and these opposites, all sides are equal length, 3.5 centimeters each. I will have a pair of opposite congruent angles. So these two angles are equal in degrees. These opposite angles are different than these two, but these two opposite angles are also equal. Okay, and last but not least, we have parallel lines that are a certain length, and these parallel lines are congruent to all the others. So that's a special feature about the rhombus. Okay. Now, for another different type of quadrilateral, we'll see here the trapezoid. In the trapezoid, we have a special shape that we will have 4 lines, but we're only going to have one pair of parallel lines. Okay, so these two lines are parallel to each other. They're not the same length. If this is 3 centimeters, then this is not 3 centimeters. Okay, I'm going to lengthen this side over here just to exaggerate it. Okay, so trapezoid is a parallelogram. I'm sorry, a trapezoid is a quadrilateral with one pair of one pair of parallel lines. We will see that all of these angles are different from each other. 1, 2, 3, 4. And one more characteristic is that all sides may not necessarily be congruent to each other. So each side may have a different length. This might be 3 centimeters. This might be 2 centimeters. This might be 3 3/4 centimeters. This might be 5 centimeters long. Okay, and that's a trapezoid. And one more type of trapezoid is called the isosceles trapezoid. And the isosceles trapezoid is similar to the trapezoid. We will have one pair of parallel lines, except for, as you might remember, in the isosceles triangle, 2 sides are equal length. So in the isosceles trapezoid, I'm going to have a baseline down here. I'll make this one go from 0 to 5. Okay, 0 to 5. Here I'll need my protractor. This angle on this side, I'll make it go up to 70 degrees. I'll do 60. This opposite side will also measure 60 degrees. Okay, and just by doing that, I ensure that this side length is going to measure 3.5 centimeters. This opposite side length should also measure 3.5 centimeters. There it is. 3.5 centimeters. And last but not least, this line down here is parallel to this line up here. They may not be the same length. They will not be the same length. If this is one measure, this will be a different measure. However, these lines are parallel to each other. Isosceles trapezoid, 1, 2, 3, 1, 2, 3. These two opposite line segments are the same length. Okay, and down here we have whatever angle measure this was, I believe I put down 60. Then this one is also 60, and that's the isosceles trapezoid. Okay, so with this classifying quadrilaterals lesson, I am able to use my protractor and ruler again. I'm always happy to do that. I would like you to also experiment with your protractor and ruler. Just have fun. I hope you enjoy this lesson. It's a lot going on, a lot of little details to consider and really think about as far as which ones are parallelograms, which ones are not parallelograms. But they all do fall under the polygon family, a multiple-sided two-dimensional figure. Okay. Thank you for tuning in. Catch up to you later. Bye bye.